Okay, welcome back. Now, this is Corollary 2, Theorem 4, or Corollary 2. This is called the constant difference theorem. And again, it's very straightforward. It's saying that if f and g are differentiable over an interval I, and the derivative of f at x is equal to the derivative of g, so f prime of x is equal to g prime of x for all x in the interval, which in other words, is what they're saying is the slopes are the same at every single point in the interval, then what they're saying is then f of x and g of x differ by a constant c. Okay? So in other words, they're parallel in this interval. Well, yeah, parallel in a manner of speaking. Okay? So this one is called the constant difference theorem. Okay? Okay. And the proof is really straightforward. So let's let h of x equal the difference between f of x and g of x. Okay, so let's define f of x. Now then, okay, what we're saying is, again, we're assuming that f and g are differentiable over an interval I, and that f prime of x and g prime of x are the same for all values of x. So if we define h of x as the difference between these two, then what we get is h prime of x is equal to f prime of x minus g prime of x. Since they're both differentiable, we can do that. Okay. And since f prime of x is equal to g prime of x, this is equal to 0 for all x in the interval I. Now, by corollary 1 that we just went over in the last video, right? So by corollary 1, what does it say? Well, since h prime of x is equal to 0 for all x and I, by corollary 1, h of x is constant. For all x in I. Which means, hence, there must exist C, constant C, I should say. Constant C such that yeah, it's just constant, right? So that means h of x must equal some value of c, right? Right? Such that h of c, or excuse me, h of x equals c, right? And therefore, f of x equals g of x plus c. for all x in I. And that's the proof. Have a great day.